In this video, we're going to take a look at topic 5.2, example 2, use properties of exponents to rewrite radicals. So in example A, we are just going to kind of play around with our properties of exponents, rewrite, maybe move it back into radical form. So if you think about it here, I have got the nth root of a times b. Well, if I put this in exponential form, I have a times b raised to the 1 over n. If you apply your power of a product property, you would be distributing this exponent to both of your factors here. So this would be the same as saying a raised to the 1 over n times b raised to the 1 over n. And then you could still move this back into radical form, and you would have the nth root of a times the nth root of b. Now, likewise, if you have division, understand you can also break this up as the nth root of a all over the nth root of b. Let's do some examples. Now, there are multiple ways to look at simplifying these. I'm going to show you one way, but again, you could have another way and still arrive at the same answer. So let's take a look. What I want to do is try to break up my factors here. I have a 16 and an x to the 5th. I want to try to find factors that are raised to the 3rd power. So when I just look at 16, so for 16, I'm thinking 2 times 8. And I can recognize that 8 is a perfect cube, right? Because 2 cubed, 2 to the 3rd power, is 8. So I'm going to break up 16 as 2 raised to the 3rd power times 2. And again, don't forget, 2 to the 3rd is 8. 8 times 2 is 16. Now, x to the 5th. How many sets of 3x's can I get out of x to the 5th? So that would be x to the 3rd. There's 3. And what's left over is going to be x squared. And again, if you think about your properties of exponents, if you're multiplying same base, you would add the exponents. 3 plus 2 is 5. So now, notice we have our index is 3. So anything I put in parentheses that has that 3 attached to it can leave the radical. So I can have a 2 leave the radical, and I can have an x leave the radical. What has to stay behind are this 2 and the x squared. We are now in reduced radical form. Okay, so here are your triads. Go ahead, pause the video. You can jot them down, try them on your own, and then come back to the video and we'll review them together. Okay, so let's take a look at 2a. Notice we are looking for 4th root. So I already know 81 is also equivalent to 3 raised to the 4th power. And again, if you weren't too certain about this, you could play around on your calculator. You could also put in your calculator, calculate the 4th root of 81. Different calculators have different ways to do this. But 3 to the 4th power is 81. So I'm going to rewrite that. '81 is 3 raised to the 4th power. And again, you're trying to get an exponent of 4, something that matches whatever your index is. Next up, I have a to the 8th. Well, how many sets of 4a's can I get out of 8? Well, if you just take 8 divided by 4, that's 2. So that means I would have a squared raised to the 4th power. And again, think about it this way too. Applying your power of a power property, you would multiply exponents. 2 times 4 is 8. Now b to the 5th. How many groups of 4 can I get out of 5? Well, that would be 1. So you would have b to the 4th, and you would have 1 left over. And again, remember properties of exponents if you want to check yourselves. If you have the same base and you're multiplying, you add the exponents. Same base, b, 4 plus 1 is 5. So now I'm going to go and I'm going to see, look, you're looking for that exponent of 4. They will undo each other. So that means anything that has that exponent of 4 in my parentheses, that can leave the radical. Anything else has to stay behind. So I can take out a 3, I can take out the a squared, and I can take out the b. And what has to stay behind is this lonely b right here. And now we are in reduced radical form. Our answer is 3a squared times b times the 4th root of b. Now on b, there's multiple ways to approach this one. I'm going to try to go the shortest route possible. So when I look at this, already I see I have an x to the 4th here divided by x. Properties of exponents say that if you're dividing same base, you subtract the exponents. And although we don't see it, understand this x here has an exponent of 1. So let me just start rewriting this. And again, I'm going to show this to you step by step. Okay, my root is 3. So here I'm going to have x raised to the 4th. And I'm going to divide that by x. And again, you're subtracting exponents. Okay, then I still have the y squared all over 125. Now, again, I'm just going to clean this up. You might not need to show this step if you're comfortable. So this is x to the 3rd y squared all over 125. So I already have an x to the 3rd. This root, the index, is going to cancel out the exponent. This x is going to be able to leave the radical. Y is squared. Okay, this cannot leave the radical. If this would be y to the 3rd, it could, but y squared is going to have to stay into the radical. Now 125 is a perfect cube. 125 is 5 raised to the 3rd power. So again, just for the sake of going through all of the steps, I'm going to write everything out. So far we have, and I'm going to put it in parentheses, x to the 3rd y squared all over 5 to the 3rd power, which again is equivalent to 125. And so wherever I see an exponent of 3, those values can leave the radical. So this is now going to be, and remember too, this 5 to the, this is still in the denominator. So this x is going to come out. Y squared has to stay behind. And in my denominator, this 5 can now exit the radical. And there we are in reduced radical form.